In this series of lectures, we're going to look at how to use SQLite on the Android platform. SQLite, in using a database on the Android platform, is a relatively advanced concept. And so we're going to need to talk about some other items that are related as well, such as what is a database? Why do we store in a database versus storing somewhere else? And then other just programming concepts like what a constructor is and what a context is. The first question we really need to ask is, where should we put the data that we're going to use in our application? We have several options. One is we can get the data or store the data on what now many people call the cloud, but it really is just getting it from a server off the web. So in other words, getting remote data that's not on the phone currently. The advantage of this is that we need to assume that the user has multiple devices, and we want to give the users the same data on each of those devices. We don't want to have data that's specific to one device if we can instead share that data across devices. But now on the flip side, if we do have the data on the device, then it's going to be a little bit better performance because we're not going to have to go over the network to get data every time we need it. And also, the quality guidelines for Apple indicate that if you have an autocomplete text, you should source that autocomplete text from local data. So both having the data stored remotely and having it stored locally, both of these options have advantages and disadvantages. One nice middle ground is what we're going to look at in our exercise, which is have the data stored locally, but then have a local copy of the data that really could be deleted and replaced at any time, which will allow us to have good performance, but at the same time, we still get the benefits of having centrally located data that can be used across multiple devices. So if we want to have a local copy of the data, how do we want to store the data? So far we've just been storing data in memory, which means as soon as we close the application or power off the phone, we're going to lose it. Another option, which is definitely available to us, is saving data to a file on the SD card or on the some kind of persistent storage on the device. And that's good for large pieces of data like images, pictures, things like that. But if we're dealing with a lot of records, then files might not be so good because there's not a standard way to query the data because it's not really structured data. We're just saving data to a file. So if we have structured data, if we have data that we want to query, a good idea might be able to store it in a database. The Android operating system provides us with, well, it looks like I misspelled SQLite here. The Android operating system provides us with kind of a mini database, not a robust database like you'd have on a server, but one that's more appropriate for the hardware and software of a phone. And that database is called SQLite. It's a compact database, and it's meant for exactly what I mentioned. It's meant for having a local copy of data to help your application perform better. So it's a subset of the standard of SQL 92, which most of the major industrial strength databases use. So Microsoft SQL Server, Oracle, DB2, those are the commonly considered large databases that support SQL 92. So it's not fully compliant to that standard, but it is a subset. It does support most of the SQL terms that we will want to use. And by the way, SQL stands for Structured Query Language. It's how we will get data into a database and out of a database, and how we can actually query data to get a subset of data that we want. So SQLite, Structured Query Language, is what SQL stands for. SQLite, this is what we're going to use in our database. One of the things that makes this not a true, fully functional database is that there aren't really any data types in SQLite. It's just however you store the data, that is the data type. Now, in this class, we're assuming that you don't have a programming background, so maybe this doesn't make sense anyway. Maybe you don't know what data type is, and if that case, don't worry about it. But a lot of times in databases we can have a very strongly typed data structure where we'll say what kind of data we can store in a certain column, what it will look like. Not so in SQLite. We just want to keep a local copy of data. So kind of like an Excel spreadsheet where you could have a row for phone number, and you have the phone number itself, but if you miskeyed it and maybe put in an alphabetic character or symbol, Excel probably isn't going to complain. Kind of a similar deal with SQLite. One significant concept of databases is this idea of a primary key. A primary key is a unique identifier for a row in a database. And one moment, I'll pull up, of course, the familiar plantplaces.com. So this is a common idea, the idea that we have a number that uniquely identifies a record in the database. So if I pull up plantplaces.com, we'll see that everything there has a unique number. So if I search on pawpaw, there we go, common pawpaw. Okay. What you'll see in the URL is that the plant ID is 82, and that's a unique identifier for pawpaw. Now if I go back and let's say I search on redbud, okay, and we'll pick the first eastern redbud, you'll see that that unique identifier is 83. So each plant has some unique number that identifies it. So here we go with our redbud. If I were to simply change that 83 to an 82 in this link, we'd see we're back to pawpaw. Okay, here's our pawpaw again. Okay, if I change it to 83, we get redbud again. So the idea that we have a number that uniquely identifies every record in the database, that's called a primary key. And many times we will allow the database to automatically increment this primary key. So we'll start with a number like 0 or 1, and then it will automatically increment every time we add a record. In other words, the first record will be number 1. The next time we add a record, it will be number 2. The next time we add a record, it'll be number 3, and so on and so forth. And we keep going like that. Okay. So to implement a database connection to SQLite in Android, we're going to need to what's called extend a class called SQLiteOpenHelper. And this is where we start getting into some advanced concepts like what a constructor is. So we'll take a look at this in code, and in just a moment here. So let's remember where we left off last time in our last video when we talked about exception handling. We remember that Android has the 3 principles, the 3 design goals, which are enchant me, amaze me, simplify my life. We don't want to make the user take any action unless the user actually has to take an action. That sounds kind of weird, but we want to make life easy on the user. If something goes wrong and we can fix it without even worrying the user about it, let's do that. So in our last presentation, we have this class called PlantResultsActivity, which pulls up a result of plants. And on line 103, what it's doing is it's reaching out over the web and it's getting plant details. Okay, it's getting a list of plants that met the search criteria. Now, if that does not work, it's going to throw an exception. By that does not work, what I mean is if there's a network outage or something like that, if we can't connect to the network, it's going to throw an exception, and it will come down to this catch block. So in this catch block, what we have is we have it just going off of our stub data. Okay, we have it going off of our stub data, which is just kind of local predictable data. It's hard-coded data. Our goal now is that we want to change this to actually go off a SQLite database. Okay, we want to change this to go off of a SQLite database. So we have this line 108 right now, which is where we're declaring a variable of type plantDAOstub, and the name of the variable is plantDAOstub, and then we're calling a constructor on plantDAOstub. We're going to change this to be an offline plantDAO. In other words, by offline, that means it's going to access local data. But first, what actually is this? We want to explore what each of these parts are here. Some of the stuff we've just done without explaining. It's going to become a bit more important now. Let's start by looking at what's on the left side of the equal sign. On the left side, we have a variable declaration. So we're declaring a variable, and the variable is named plant DAO stub. What does that mean? That means we're allocating space in the computer's memory, in the computer's RAM, for some information, and we're going to name that place in memory plant DAO stub. Okay, now because we're reserving space in memory, we have to say what's going to go in that space in memory, and we're saying an object of type plant DAO stub will go in that space in memory. That's what's on the left. In the middle, we have the assignment operator. What that means is do whatever activity is on the right, take the result of that, and store it into this variable that's declared on the left. So what's on the right? Well, the thing on the right is called a constructor. A constructor is where we create or instantiate an object. And by instantiating an object, that means we're basically initializing it. And any of that initialization will happen in a constructor. So let's take a look one step at a time. Let's say I want to make, instead of plant DAO stub, let's say I want to make a new class. And this new class is going to handle access to data using SQLite, using the local database. Because I don't need to be online, I'm going to call this offline plant DAO. That's going to be the class. I have not yet made it. And then we'll call it offline plant DAO. So I've just declared a variable. The variable name is offline plant DAO with a lowercase o. The variable type is offline plant DAO with an uppercase o. On the right, then, I'm going to call the constructor for this offline plant DAO. I'll say equals new offline plant DAO. Now this is going to redline because as of right now, offline plant DAO does not exist. So let's make it. I'm going to comment that out to take away the red line for the moment. I'm going to go to com.plantplaces.dao and I'm going to right click and I'm going to say new and then we'll say class. Okay. And for this new class, I'm going to say, we'll call it offline plant DAO. Okay. And the superclass. Now, if you remember back to the presentation, whoops, wrong presentation, sorry. If you remember back to the presentation, we said that we have to extend a class called SQLiteOpenHelper. So in the superclass, this is where I'll hit browse and delete Java lying object. And I'm going to type SQLite. My Q key is stuck. There we go. SQLiteOpenHelper, just like so. Okay, and I'm going to select that. Why do we have to do this step? This class called SQLiteOpenHelper has some of the wiring that will help us link up to the database. So we have to set up a relationship between our class that we want to do the heavy lifting of saving to the database. We want to connect that with the SQLiteOpenHelper that has some of the methods that will help us interact with that database. So after I choose this, I'm going to choose finish. Okay. Okay. So we have offline plant DAO and I press Control and M. And SQLiteOpenHelper defines a couple of methods that it wants us to put some implementation towards, and that is onCreate and onUpgrade. We'll come back and look at those methods in a moment, but when you set up this relationship with SQLiteOpenHelper, when you set up this extends relationship, it automatically gives you onCreate and onUpdate. It automatically gives you those two methods because SQLiteOpenHelper says, hey, I want you, the implementer, to decide what you're going to do when these methods are called. Now, just kind of a quick foreshadow of where we're going with this. OnCreate is going to create the database schema or the layout of the database that we're going to use. And then on upgrade, we'll handle how we do upgrades to that database schema. Okay, so first of all, if we go back to plant results activity, we remember that what we're going to want to do, we'll go ahead and leave this uncommented for now. What we're going to want to do is have a constructor that sets up any initialization information. Okay, a constructor is similar to a method, but it has a special syntax. It looks like this. It has oftentimes the word public, although it doesn't necessarily have to be public. And then the name of the class itself, offline plant DAO. And then we can have any arguments. I'm not going to put any arguments yet, but we will adjust that. And then open curly, close curly. Purely using this syntax, purely by using this syntax, we're saying that this is a constructor. Okay, offline plant DAO is a constructor. If there's any information that we require to initialize this object, we can pass it through as a parameter to this constructor. And the reason why I say that is that SQLiteOpenHelper actually requires 4 pieces of information that we're going to need to give it. Let's see what those 4 pieces of information are. I'll go back to my browser, open a new tab, and I'm going to say SQLiteOpenHelper. And let's see what it says. When we look at the documentation for SQLiteOpenHelper, what we see are the constructors. And the first constructor is just like the constructor we were just making. This contains any prerequisite information that is required to set up the object itself. Now the first constructor is the one that we'll use, and it requires, number 1, a context. What's a context? Well, believe it or not, that's an activity. The reason why we need a context is it will tell us about the sandbox for our application. Now, what's the sandbox? The sandbox is an area where our application can play without affecting any other applications. So it's kind of a private data area, and it's where our database will be stored. As soon as I start up a debugger window, we'll see what the sandbox looks like for our application. So we have to pass it a context. Next, we need a database name. Let's just call it plant places. We can pass that in as a string. Next, we need a cursor factory. This is optional. We can just pass in null, which is what we'll do. And finally, we need a version, which is just the version of our data structure that we're defining. So we'll start with version 1. In the future, maybe we'll have a version 2. But right now, we'll say plant places for the name. We'll say null for the connection factory. And we'll say version number 1. The context is going to be a little bit more tricky, so hold that thought for just a moment. We'll look at that in just a moment. Now, here's the trick though. This is SQLiteOpenHelper, and we need to pass data up to this SQLiteOpenHelper because we extend SQLiteOpenHelper. So the way we pass this prerequisite data up is by using a keyword called super. And then we pass the arguments in the list that we saw. Let's just put in a CTX. We'll just keep a blank for that context right now. For the database name, we'll say plantplaces.db. Really could be anything. Null for the cursor factory, and then version 1. And we're good. Now we have to define what that context is. But the trick is, look at where we are. Do you see an activity here? There's no activity here. So we don't know what the context is, which means guess what? That's going to be prerequisite information that we're going to need when our offline plant DAO is constructed. So let me make that an argument here in our offline plant DAO's constructor. By argument, I mean a parameter that should be passed in. I'm going to say context CTX. And suddenly, I'll Control-Shift-O and organize imports. Suddenly, everything here will compile now. Everything here will compile. Given that, we can go back to plant result activity, and let's see what we have there. I'm going to Control-Shift-O here, and all of a sudden, almost everything compiles. And by the way, I'll take out this line above. Almost everything compiles. Actually, I won't do that yet. What doesn't compile? Well, this constructor call. Because what it's saying is that we need to have an argument that matches. You see how we're calling offline plant DAO and we're not passing anything in? What we're saying here is, what that red line is saying, if you're going to call offline plant DAO, you need to pass in a context. Now remember what I said a context is. A context is an activity. And the good news for us is, guess where we are? We're in an activity, plant results activity, and that will give us a context. So what we need to do is we need to pass in a reference to the current object. That sounds kind of weird, but we need to pass in a reference to the object that we're currently in. In other words, we need to pass in a reference of this plant results activity. We can do that simply with the keyword this. And all of a sudden, magically, save, and, well, hopefully everything will compile. Let's give it one moment here. Oh, okay, I'm sorry. I have to do one more tricky thing for this. I have to say plant results activity dot this. I have to tell it what I'm passing in. Okay, and suddenly everything compiles. Okay, so I'll comment out the line above, and I'm going to change, well, we'll come back to that. Suddenly everything compiles because we are constructing this offline plant DAO by passing in any necessary information, which is that context. We're passing the context up to our SQLiteOpenHelper, and we're also passing in the name of a database, a null for the cursor factory, and the version number 1. Okay? So what I need to do now is where I'm calling fetch plants, I'm going to call that on offline plant DAO. And now what we need to do is we need to add this fetch plants method to our offline plant DAO. What's nice is that Eclipse will do this for me. I just have to click this option, create method fetch plants, and type offline plant DAO. So I click this, boom. Okay, and that's good, that's good, that's good, that's good, that's good. Now what we've done is we've created this method, which we are going to use, and I'll put some comments to this effect. This method will search the SQLite database, well, let's say the local SQLite database for plants that match the search criteria. Okay, and save. Okay, in plant results, I'll go here, clean this up, and save. See if we have everything compiling. And right now we have everything compiling. So the next thing that we want to do is we want to actually create our database. And then we want to think about how we're going to put records into our database. And then we want to think about how we can retrieve records from our database. So right now we've gotten everything set up. Next step is going to be to actually create that schema. We're right about at 23 minutes on this video, and I like to kind of keep them right around there. So let me go ahead and pause this and upload it, and we'll call this part 1. And then in part 2, we'll go through and define the schema, and we will also define how we're going to insert into the schema and pull out of the schema. Thank you.